Get ready to take notes. Hey there, welcome back. This is Miss Anna's virtual classroom. You might hear some hip hop or some dogs barking in the background. Get your notebook ready because this is a lesson on equivalence, and this is the next step where we find out why is it useful, and we also think about how to use it to add unlike fractions. So Emmy drew this, isn't it great? All right, so let's review equivalence. Equivalence has the Latin root word equi, which translates as equal. So what we're trying to do is make the same quantity, but we're kind of trying to find a way to rewrite the fraction differently. So let's say, why is it useful? Let's say you're new to the United States and you don't know about our money, and someone tells you that an apple costs a half of a dollar. Well, you don't always know stuff like that if you're brand new to the country, so you might know that the dollar actually has 100 pennies in it. And so maybe you could think of, okay, what's half of that? So if we think of a dollar being 100 pennies and we want to get half of it, we can think of an equivalent ratio with pennies. So, and some of you are thinking 50-cent piece, yes, but sometimes when people are new to the country, they don't know our monetary system. So the rule is the same rule we used before. Whatever you do to the denominator, do the same thing to the numerator. What happened to 2 to make it grow to 100? That's right. We multiplied it times 50, and we got 100. So whatever we do to the denominator, we need to do the same thing to the numerator. So 1 times 50 gets us 50 hundredths, or 50 cents. So that's a way to get an equivalent fraction. And later we're going to need to use that when we're changing fractions to percents. Again, whatever you do to the numerator, do the same thing to the denominator. And we usually will divide by the same, using the same number, or we will multiply using the same number. All right, so let's go to how does this apply when we are adding unlike fractions? Okay, and remember in the earlier video I told you guys this is connected to ancient Egyptian history, and I just Googled what Wikipedia Egyptian fractions, and I found some of the fractions we're going to use later in this because Egyptians were really good at this. They built a lot of cool stuff. All right, so let's start where we have 2 unlike fractions. So we're adding unlike fractions today. 1/4 plus 1/2. And they are unlike because, do you remember why? Because they have different denominators. And I always tell you that we have to get the denominators to be the same before we add them, unless you're using a table, especially an ancient Egyptian table. So what we want to do is get these unlike fractions. The numerators are the top numbers and the denominators are the bottom numbers, and unlike fractions mean they have different denominators. Okay, so let's get them to be the same. When you look at the denominator, you need to think, is there a way to change one or both of them so that they become the same? And does anything come to mind? All right, we're going to leave 1/4 the same, and we're going to change 1/2 because we can make that have a 4. So whatever we do to the denominator, do the same thing to the numerator. How do we make that a 4? That's right, you multiply by 2. And whatever I do to that denominator, I'm going to do the same thing to the numerator. My new fraction is going to be 1 times 2, 4 in the numerator, and then 2 times 2, 4 in the denominator. So I ended up with 1/4 plus 4/4. Sorry, 1/4. 1 times 2 is actually 2. 1/4 plus 2/4. And then all I have to do is remember the other chant. The other chant said, add the numerator plus the numerator and write a number. So add the numerator plus the numerator and write a number. 3. And then leave the denominators the same for now. and then I can check it by going backwards. 3/4. If I take away, if I say 3/4 minus 2/4, do I end up with 1/4? Yes, that works out. So my final answer there is 3/4. Okay, let's get a little fancier. Let's try another one. Okay, if this is going too fast, you can always pause it or replay it. All right, the next one is 2/3 plus 1/4. And I was a little embarrassed earlier to make that mistake, but as long as you are rechecking, you're going to catch your mistakes. That's why I always want you to use scratch paper, because you can learn your common mistakes and get better at math. So I've got 2/3 and 1/4. They, again, are unlike fractions because the denominators are not the same. We have a 3 there and a 4 there. So this time we're going to change both of them. And so what we're going to do is when we look at 3 and 4, we have to think, what can we do with that? Well, I know number 12. They both go into 12. So I take this first fraction and I say, how do I make this denominator 12? I focus on the denominators first. And the way I do that is I multiply this number by 4. Whatever you do to the denominator, do the same thing to the numerator. And then I'm going to change this one too. 1/4. I can make that 4 become 12 by multiplying it by 3. Whatever I do to the denominator, I need to do the same thing to the numerator. So I got a new set of fractions here. Once I multiply it out, 2 times 4 gets me 8. And then I have 3 times 4 as that lucky 12, what I want. That's the number I wanted. Plus 1 times 3 is 3, and then 4 times 3 is 12. So then I need to add everything together, and I add up 8 plus 3. Remember the chant? Add the numerator plus the numerator and write a number. 8 plus 3 is 11. And then, okay, sometimes people get stuck with 8 plus 3. So let me show you a self-help tip. If you get stuck with 8 plus 3, don't be shy about it. Just write some notes. You can say, okay, I know what 8 plus 1 is. That's 9. 8 plus 2, that's 10. 8 plus 3, that's 11. So this is a way to write little self-help notes if you're getting stuck with your basic facts. Don't be shy about that. This is why we have the scratch paper. And so 8 plus 3 got me 11. And then I'm going to leave the denominator the same for now. And that's my final answer there. I say, okay, 11 twelfths, take away 3 twelfths. Yes, I got 8 twelfths. All right, so let's turn it up a little bit with the ancient Egyptian stuff that I found on Wikipedia. Again, I Googled Egyptian fractions. And they are really good at using tables and having systems for unlike fractions. And so let's use some equivalence to check Egyptian work. And yes, I know they are notoriously famous for outstanding math, but let's check the math anyway. So I looked at the table and I found 5/8 plus 1/2 plus 1/8. And I need to see, is this all going to end up being 5/8? All right, so what I can do is I can change this first number to have an 8 in the denominator. You don't always have to change both of them. So if you look at it for a little bit, you think, what am I going to do here? And you don't have to change both of them. So I'm going to say that 1/2, I want to change this to have 8 in the denominator. So what do I multiply times 2 to get 8? Right, 4. Whatever I do to the denominator, I'm going to do the same thing to the numerator. So after I change this and make it an equivalent fraction, I'm going to end up with 1 times 4, which is 4, over 2 times 4, 8. Yay, I got my eighths. Okay, and now, is it true? Does 4/8 plus 5/8 equal 5? Does 4/8 plus 1/8 equal 5/8? Yes, it does. It came true. So that's really a great thing. The ancient Egyptians were correct. And now let me give you a harder one. All right, so get your pencils ready. Let's do another one. And here we go. We're gonna do 13/12 equals 1/2 plus 1/3 plus 1/4. All right, what do you do when you have a lot of numbers? Well, what you have to do is just think of all of it together. Is there a way to make a common denominator? So look at it for a little bit, and do you think you can make a common denominator? All right, so the first thing I thought of was, again, 12. So I'm going to multiply 2 times 6 to get 12. And I also want it to all be 12 so I can check it. I'm going to multiply 3 times, whatever you do to the denominator, do the same thing to the numerator. 3 times 4 to get 12. Whatever I do to that denominator, I'm doing the same thing to the numerator. And over here, 4 times 3, whatever I do to the denominator, I'm going to do the same thing to the numerator. And I ended up with 6/12. 1 times 6, 6. 2 times 6, 12. Plus 1 times 4, 4. 3 times 4, 12. Plus 1 times 3, 3. And 4 times 3, 12. Now the big question, did we end up with 13/12? So we just add them one at a time. Again, don't stress out. If you need to do side notes, that's okay. So 6 plus 4 gets me 10/12. And so I'm adding the numerators, and then I'm going to leave the denominator the same. So 6 plus 4 is 10, plus 3 is 13. And I'm leaving the denominator the same to see if I ended up with the same stuff. And I did end up with 13/12. All right, and in case you're wondering what this is our little happy cloud system saying that's the final answer. And I'm really happy. Looks like the ancient Egyptians were onto something. Sorry that the screen was a little bit twisted. Thank you for putting up with me. Have a good rest of the day. Phew, that was harder. Thanks for watching.